All right, so we were talking about moments of inertia, and so I've got these two cans right here. This is a cat food can that's got cat food in it. This is a cat food can that's empty. And so what's going to happen is I set them both up here. One of them is going to have a bigger moment of inertia than the other one. So that means that they roll down, then some of the energy of going down the incline is converted into rotation. So the one with a bigger moment of inertia is going to have more of that energy. Now, they're rolling down, so they have the same change in potential energy. So that means that some of the energy in the cat food can with cat food in it had to go into rotating more so than with the empty one, and so the result is that the empty one got to the bottom first. Okay, now here is a bean can that's also empty, and so if I set both of these up here together, they're both empty cans, so the moments of inertia should be roughly similar in form. Now they're not the exact same because they're different masses, but the equation for the moment of inertia should be the same. And so since the equation is the same, if I let go, then they go down the incline together. Okay, and so that's an indication here that our what we're doing actually seems to work. Now here's a ball. Okay, now we know that the sphere has a smaller moment of inertia than a cylinder, and so therefore it should make it down the incline fastest. And in fact it does. Okay. And so, and again, you know, even these cylinders were closer together than the sphere and the cylinder. And that's because the moments of inertia here are closer together. And so this is how all this relates. So two objects rolling down the incline are going to get down the bottom quicker or less quickly depending on the moments of inertia.